Alright guys, so now let's talk about the section 3.7 topic in the theory of polynomials part 2. First of all, I would like to remind you that you need to know this theorem, the conjugate theorem, the fundamental theorem of algebra, as well as the number of zeros theorem. So let's take a look at the example number 1 if you want to. So they are telling you that 3 is a 0. What I like to do, personally, and you will see that in a few minutes why, but what I like to do is understanding what does that mean 3 is a 0. 3 is a 0, that means x equals 3, so I can have x minus 3 equals 0. Why do I want to do that? Because I know that my polynomial is a polynomial degree 3. So that means that my polynomial p of x can be written as p of x equal the multiplication of 3 parentheses. Each of these parentheses is going to help me to find a 0. And for instance, I know one of them. It is x minus 3. Okay? So the idea is, if I want to find the two other parentheses, what I just need to do is take my p of x divided by x minus 3, and I will find my two other parentheses. Maybe not right away factorized, but at least I will find a polynomial that's going to help me to find my two other parentheses and find my two other zeros. So first thing and what I want to do is try to divide, and I'm going to take negative 3, and if I take negative 3, I will have 1, then minus 7, negative 7, 17, and negative 15. And I'm going to apply what I've done previously. So I'm going to have is I bring down the 1, I multiply negative 3 by 1, which is negative 3, but I do subtract. Okay, that's the beauty of it, is I'm going to subtract, and so I'm going to have negative 4 now. Then I'm going to have plus 12, and because I subtract, I end up to have negative 12, 17 minus 12 equal plus 5. Then negative 3 by plus 5 equal negative 15, but because I subtract, the negative 15 is going to become plus 15, and I end up to have 0. Is it normal to have the 0? Yes, because I know that with my parentheses x minus 3 equals 0, I'm supposed to have x equals 3, and I know that is supposed to be a 0 of my polynomial. So now I can definitely say that I have a second polynomial, which is a polynomial degree 3, and this polynomial degree 3 is going to be x squared minus 4x plus 5. So the whole idea is to transform this polynomial x squared minus 4x plus 5 into the product of two parentheses, and each of these parentheses is going to give me the last two zeros of my initial polynomial p of x. For that, I can decide to factorize right away, x squared minus 4x, and that's pretty simple. First of all, if I do it, I'm going to put a plus right here. Like this, I know that I will have a plus inside my parentheses. Then, because x is standing by itself, I will have x right there. How to have 5? Well, to have plus 5, it's very, very easy. I'm going to put a 1, I'm going to put a 5, because 1 by 5 give you plus 5. The last term that I want to check is negative 4x, and the only way to have negative 4x is to have a negative 5 and a plus 1. That implies thus that we having x equal 5 and x equal negative 1 as a 0 of your polynomial p of x. And so we having 3 zeros. The first 0 was 3, and the last two zeros are 5 and negative 1. Now, let's take a look at this example number 2 about how to find all the zeros of a polynomial. In this case, a polynomial degree 3, because we're having 8x cubed, and the leading term has an exponent equal to 3, so it's a polynomial degree 3, and we are kind of expecting at the most to have 3 zeros. For that, we are going to use the rational zero theorem. And the rational zero theorem is pretty simple. If we're having a polynomial, and this polynomial is defined with a qx to the n plus a series of expression of x, and then we're going to have at the end p, well, we are going to define all the possibilities for P and all the possibilities for Q. And once we will be done defining all the possibilities for P and Q, we will have to calculate P divided by Q. P divided by Q for all the possibilities. Once we are done defining all the value of P divided by Q, we just need to take each of these values, substitute this value of P divided by Q inside the polynomial P of x. Instead to have x, now we are going to have P of P divided by Q. And some of them are going to be equal to 0. Some of them are going to bring my P, my polynomial, equal to 0. And when the polynomial is equal to 0, well, we found the 0 of the polynomial P of x. Okay? Of course, that is a long and facetious, so what I want to do is, using my calculator, graph my function and try to see if there is an easy 0 that I can take from my graph. I can see right here that when I'm using my calculator, I'm having a P of x equals 0 when x equals -3. Right there, when x equals -3, P of x equals 0. So, right away, I know that x equals -3 imply x minus -3 equals 0. Or should I say x plus 3 equals 0. And so my P of x is equal to x plus 3 time another 2 over parentheses, because I'm expecting to have a polynomial degree 3, so 3 zeros. And so I know that at some point I will have to divide P of x by x plus 3, and that is going to help me to define my 2 other parentheses, and so my 2 other zeros. What I want to do is exactly what I've done before, which is using P of x, and so it's divided by x plus 3. I'm going to take plus 3, and so now I'm going to divide using the synthetic division, okay, my -15. I bring down the 8, 3 by 8 equals 24, and I'm subtracting, okay, I'm subtracting, so I end up to have a 6, and then I end up to have a 18, I'm subtracting, so I end up to have a -5, I'm getting a -15, I'm subtracting, and I get 0. And so my P of x divided by x plus 3 is going to be 8x squared plus 6x minus 5. And to find the factorization of 8x squared plus 6x minus 5, factoring directly, it's very difficult. I'm going to use the expression of your quadratic formula, and I'm going to find the 2 last value of that makes your polynomial equal to 0. And at the end of the day, when I find x equal 1 over 2, 1 divided by 2, that means x minus 1 over 2 equals 0 is one of the 2 parentheses. And so x equal -15 divided by 4 imply x plus 15 over 4 equals 0. Okay? All right. That said, let's take a look at the example number 3. In this example number 3, we have to define the value of P and the value of Q. P equals 5 when Q equals 6. P equals 5 and Q equals 6. That implies that we are going to have, for different possibility for P is going to be plus or minus 1 and plus or minus 5. There is nothing else that we can have. When for 6 we can have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Then we are going to define all the P divided by Q possible. And once we have defined all the value of the fraction, we are going to substitute this value inside your expression of P of x. So I'm going to have P of P divided by Q, and the one who is going to make it equal to 0 will be the 0 of your polynomial P. Okay? But I guess we can still do exactly the same thing that we have done previously. We can graph the function. When we're graphing the function, we're realizing that x equal minus 1 is a 0 of your function. Because x equal minus 1 is a 0 of my function, I can define x equal minus 1, so x plus 1 equals 0, and so then I can use my synthetic division and divide by doing plus 1 and using the different coefficient like 6, 5, negative 31, negative 25, and 5. I'm applying the same methodology. I bring down the 6. Once I bring down the 6, I end up to have a 6 right here. I subtract, and I end up to have a negative 1. Then I'm going to have a negative 1, I subtract, and I'm going to have a negative 30. Then I'm getting a negative 30, I subtract, and I got a plus 5. 1 by 5 equals 5, I subtract, and I got a 0. Then I have a 6. My polynomial, let me get back to the polynomial because I forgot. My polynomial is a polynomial degree 4. So now I got a 6x cubed minus 1. So minus x squared minus 30x plus 5. And what I need to do is try to find, and again, try to transform my 6x cubed minus x squared minus 30x plus 5 into into 3 parentheses, because I'm supposed to have 3 zeros from x cubed from the polynomial degree 3 that I have right now. And for that, I'm going to look at my graph again, and I can see that my graph right here is equal to 0. My function is equal to 0, but this time for x equal 1 over 6. So I'm going to do exactly the same thing, which is I'm going to take x equal 1 over 6 as a 0. So x minus 1 over 6 will be the first parenthesis of this polynomial degree 3. And so I'm going to use my synthetic division to find the answer. And so for that, I'm going to do is negative 1 over 6. And then I'm going to have a 6, negative 1, negative 30, and 5. I'm going to apply the definitions, bring down my 6, multiply 6 by negative 1 over 6, can give me negative 1. I subtract, so now I got a 0. I multiply by negative 1 over 6, I end up to have a 0 right here now. Okay, now I got a 0. I subtract, doesn't change anything, negative 30. And then I multiply negative 1 over 6 by negative 30, and end up to have a plus 5. And I subtract, and at the end I end up to have a 0. So now I know that my second 0 is x. I knew that my second 0 was x equal 1 over 6. So from this right here, I'm going to end up to transform my 6x cubed minus x squared minus 30x plus 5 into a 6x squared plus 0x minus 30. And then to find the answer to that, how many zeros from 6x squared plus 0x minus 30, that's super easy because 6x squared minus 30 equals 0. So 6x squared equals 30 and x squared equals 5. So I end up to have x equal plus or minus 5. Plus or minus 5. And now I got my 5 zeros. The last two zeros plus 5 negative 5, then 1 over 6, and then negative 1.